All right, so the first thing to do is to draw a diagram. Now, if you don't know how to get started, know what you know how to do. It says a 15-degree ramp with Brad sitting on it. So what should I probably draw? 15-degree ramp with Brad sitting on it. Brad, you're also going to be a box, so I can't draw people that well, okay? Okay? All right, now this is the thing we need. It says to calculate the force of gravity that's parallel and perpendicular to the ramp. Because as you may or may not know, you can still, even with Brad sitting on that 15-degree ramp, he still feels it on the soles of his feet. If you guys ever been on, try to climb things that are steeper, it's harder to climb, right? Like as you get things that are steeper. So the more of the gravity will be pushing backwards, pushing you down instead of going across it. So let's go through. What direction for anybody is gravity always? Gravity is always straight down. So force of gravity equals mg. Always. And people are going to not like me for this. I use 6.81 and I encourage you to as well. Sorry, 9.81. Sorry, that's 9.81.
Why the extra one?
Because I'm exempt. Yes, go ahead. Question?
What is that?
That's just a new equation to memorize for this year, okay? That's just the regular force of gravity. So it's always, the way it's been calculated, is that we're going to say every kilogram that you weigh causes 9.8 newtons of force on the ground. That's the G of F, G equals mg.
So it's just a constant.
It's just a constant. So 9.81 always stays the same. Okay, the 60 would change. Yeah, F equals ma at the same time.
Yeah.
Sorry?
Well, it's on the surface. Yeah.
All right, let's not, I'm not going to, this is calculus I'm stating just on source zero right now. Yes? M is the mass. M is going to be the mass of the object. Okay, so G is the force of gravity. G is the force of gravity. Okay, can somebody get their calculator out, please? Going out here. Awesome, that's you. What's 60 times 9.81, please? 588.6. Okay. So what that means is there will be a force of gravity going downwards, which is 588.6 newtons. Okay? Now, gravity will, the thing is, we want the force of gravity, it says perpendicular and parallel to the ramp. Okay? Can somebody be brave and tell me how I would find the force of gravity that's going to be parallel to the ramp? Now just think, if you need to draw another picture, you can draw another picture here. This is all going to involve trig here. Alright? Anyone want to be brave and you take a stab? Go ahead.
I mean, technically, you have like a right angle triangle there.
Yes, you do.
So you could find like the top now, and then you could use a law of some sort for trig. A law.
Yes, but I'm going to say this. Let's redraw this for a second. Because this is the way you have to think here. In order to get the force of gravity, it's going to be the force horizontal plus the force vertical. Okay? Now the way you're saying, Chris, would work if you're adding this plus this equals this, but it doesn't. Okay, right? So what we're going to say is it's going to be this vector here plus this vector here is going to equal the bottom vector. Okay, so we're okay with the logic here. This is the key point here, okay? Stay with me, I know it's been a long class, okay? You're going to add the horizontal component to the vertical component, and that's going to give you that's gonna give you FG. Okay, so what I'm gonna do, I'm gonna redraw this if you don't mind. Okay, so the horizontal component is gonna go down sort of like this. This is FH. Okay, the vertical component is gonna go sort of like this. Oh, wrong way, whoops. The vertical, whoops. Try that now. And this together is going to equal 5. Okay, just wait, just wait. Just if you're thinking, Billy, this all I'm saying is, this vector right here is going to, I'll do it in blue on which you can see. This right here is going to be the horizontal force, right, backwards down the thing.
Okay.
And then the vertical force is going to be down like this. Okay, so imagine you're on a ramp, okay, imagine you're snowboarding and you're going up a mogul, okay, right, the idea is you're being pushed back, right, okay, so your feet are going downwards compared to the surface, but you're also being pushed back at the same time.
So basically, the FH and the FB are kind of like Brad's point of view?
Yeah, exactly, very good, very good. That's an excellent way to put it, okay, so this is like from Brad's point of view. Again, he's on the ramp, so he's looking forward, that's a VH, and again, his feet going down as a VV. There's one other thing I can put on, I can put some angles on this. How are FH and FV connected? What's the angle between FH and FV?
90 degrees.
90, right? Now we gotta get some more vectors in here. Let's deal with FH maybe, because that might make my life easier. If right at the beginning, I was told this little guy was 15 in there, what does that make the top angle then? Yeah, quick.
Like for the whole 5 again, is that going straight down?
Straight down, yes. Gravity always goes straight down, right? You're always going straight. The blue line? Which is this blue line or this blue line? Because, okay, what you're saying is, can I do this? Ah! No. Control Z, Control Z. Oh. Okay, I'm gonna use the power technology. Oops, I wasn't using power technology, maybe I still can. Okay? So according for Brad, what you're saying is Brad is seeing it as horizontal, right? And then vertical. So that's what Brad looks like. There's gravity going down this way, plus there's also going to be a force going backwards that's causing it not to stop. Gravity, according to Brad, because he's on the lamp, is not going straight down, it's going at an angle. Right? That's what's supposed to be happening. Okay? I hope I didn't move that. Okay? Which, the left or the right? This one here? Okay, because think what we're saying, okay, hold on a second. Because compared to Brad, there has to be, it said we want a force that's horizontal and vertical compared to Brad. Okay? So this is going to be the horizontal one. Oops, same thing I did before. Right? Horizontal one is, well, that didn't work at all. Horizontal one is going to be this way. Vertical one should be up and down. And then you add those together and get gravity. Okay, that's what's supposed to happen. Let's quickly put that back together.
It's just in general, all these questions that you're giving us are just kind of like a net force.
This is, yeah.
Finding.
Yeah, but this one is like the level 1 question, and we're moving on. All right, let's solve these components here. So this is 2075. Let's do this quickly, guys. Time is running here, okay? So that's 2075. This is a right angle. We'll say that FV, or we'll say opposite, right bodies, sine 75 degrees equals FV over 588.6. So FV equals 588.6. Okay, so basically, that's the way you just use flow controller to do the on-ramp, parallel to ramp. You guys want questions to look at for the weekend? No, do your assignment, okay? I will go through the,
Mr. Cowley, could you call extension 3003? Mr. Cowley, call 3003.
I'll start with another example of this on Monday, okay, and then I'll do some vector proofs probably.
Oh, yeah.